I hope this Friday found you all well and safe. Good morning, good afternoon, good evening, depending where you are. And welcome to Hangout with RAKStars. Happy to be here once again with all of you. And for all of those who are joining for the first time, Hangout with RAKStars is just a community space where we share with community members to share about their cool projects, their hacks, and the many other experiences they are working in. My name is Maria Hernandez, Developer Relation Lead, and not like every Friday, and in today's session, I am with Johan Macias, our developer advocate. How are you doing today, Johan? Excited?
Yeah, I'm really excited to be with you today.
No, it's super nice to have you. And yeah, like Johan is our today guest. We have an internal guest this week since we want to show something cool that our team is working on. And yeah, Johan has been joining us in a previous session, so we're not going to talk a lot about like his experiences in the industry in such details, but rather he's going to bring us an introduction about something that, as I just mentioned, the RAK team is working on, and it is the WisBlock API. This is an open source tool that makes the development of event-driven power applications easy. So now you can just use the WisBlock API and let them to take care of the LoRaWAN, BLE, and AT commands functionality with just a few configurations. So yeah, that's all. And for those who have any question to Johan over the session, feel free to leave it on the comment section, and we'll be super happy to address any question you may have during our Q&A session at the end. So Johan, you already have been on the show, as just mentioned. So our active community members that join us every Friday probably already know you and I already know about all the things that you have been doing during the past months with RAK. Anyway, if someone is watching us for the first time, will you please share more details about yourself, your background, your education, and how you got into this world of IoT ecosystem?
Sure, this I need will be a little quicker than the last time. I am an electronics engineer, and I started in the IoT world when I was in the two last semesters of my college degree, with a project. That project was a mix of computer vision and IoT because um, we were using a classifier to identify facial expressions on facial expressions from people and sending which emotion was recognized by the algorithm to the cloud. That was using a Raspberry Pi and some OpenCV stuff in that time. And I started formally at IoT when I started my internship. That was in the last semester of my career. Um, and I started to work in a company here in Medellin, which main focus is IoT. So there I started to learn about more protocols in IoT, security stuff, and all the things that IoT involves.
Amazing, amazing. And now that you are part of the RAK team, could you share a bit more about your experience working with the team as well as the different activities that you are currently involved with?
Sure. I'm the one of the last projects that I shared in I shared in the last section. It was the data only hotspot configuration to run your own light version of hotspot to use with the Helium network like a miner, but without the mining features. Um, that's one of my main projects to share because I have been working on in other projects as well. And the recent one is the one that I'm going to talk with you today, which is how to start with the WisBlock in an easy way. And every day, all the RAK thing is working in many new features to make it even easier for those who are just starting.
Yeah, that is like our motto, right? Like IoT made easy, and that is why we are working like that is what our goal to develop like any hardware product or any software product for our community members and for our customers for sure. And I don't know if there is like any other contributions that you would like to share, like maybe that are not directly related to the company that you would like to share with us today.
There is an interesting project that I started to work this year. It's that I'm participating in the IoT Medellin community. This is a local community, and we meet every 2 weeks to talk a little bit about what's going on in the ecosystem around the city. And because uh, of this pandemic stuff, we are not only Medellin community, we are expanding a little bit more around the country, and sometimes we have people from other countries as well. But we are focusing on what's going on here in Medellin, and that's a really a space that I share with Maria as well. And yeah, and in that community, we started um, the coverage mapping of the city, the healing coverage mapping of the city, because we already in the city there are several hotspots deployed at this moment.
Amazing, amazing. Actually, like, it's super cool to see how like I wouldn't say like super big, but it's too big if we compare it of what we used to have in terms of LoRaWAN coverage in the city. It's pretty cool to see that now anyone who wants to start tinkering with this technology, they have an open network that they can just start using and thinking it. And the idea with this that you just shared is to also like encourage all these people to start using it, and also to help us to validate that coverage for all of those who want to deploy and really use this network in the IoT way in some way. And also a cool like milestone to highlight here about that. I could say that like we are, if I'm not wrong, like I have been checking all the mappers map in South America, and we are the first city in South America who start like collaborating and contributing to the Mapper project. So it's really really cool to see that. But yeah, without further ado, I invite to all of you who are connected to watch the session number 37, if I'm not wrong, right? I think it
I
was the
think so.
37. Yeah, the 37, where Johan shared in more details about his experience working in this industry, in more detail about the different projects he is working on, as well as present how to deploy a helium data only hotspot. And just to re-clarify once again, this is a hotspot that doesn't have the ability to mine, as the name itself, it's a data only hotspot, just to clarify that. So yeah, now let's jump in the conversation that we bring for today for our RAKStar, which is the WisBlock API. And I know that you prepare a deck for us to give a little introduction about this new project, and as well as a demo to show you how to get started with it. So the stage is all yours.
Okay, so this is a quick start with the WisBlock API for your next LoRa or LoRaWAN application. And one thing to highlight before to start, it's this is a brand new flavor of the tools that you have for the WisBlock ecosystem. So there are there are many features that I'm going to show you right now that are not available to test with just one click, but you can start to explore it with the things that I will show today. So we have the WisBlock ecosystem. WisBlock modular hardware components allow us to realize our ideas by clicking blocks together. That's super incredible from from the hardware side, where the things were a little harder before. And The idea today is let's make a little bit easier the application development as well. So all this started with a project from one of our co-workers at one of the members of our team, which is Bern, and he started to talk about this in this way. Every time I get a new prototype, module from RAK, or a new application idea pop-ups in my mind, I start to create a new project folder, then copy all the basic functionality that I usually want from other projects into it. And I think that is basically, this is basically what many of us do when starting a new project. However, Bern continues talking about this. Kind of wasted time and easily leads to mistakes. So I thought if I have a ready to use project folder, the call container, with all the basic functionality read that makes it much easier. Just copy the folder, rename it, whatever your application is doing, and concentrate on the implementation of your application specific code. When I read this introduction for the first time, I felt the same feeling about this, because the WisBlock ecosystem already have many examples for every one of the modules and sensors, and they are ready to use and focus on that specific sensor. But when we want to start our own project, sometimes is a little bit complicated to start connecting all the blocks together, because we were thinking about the basic functionality. For example, how to set up the LoRaWAN stuff, how can I upload the LoRaWAN credentials, and many things that could be already done in a basic firmware. And these kind of basic functions, it's what Bern leads here. For example, he talks about the initialization of LoRa and LoRaWAN, and the support for all LoRaWAN regions. You know that when you are working with LoRaWAN, you need to take care about in which region you are, and if the hardware that you are using supports all the regions. Another function is timer for frequently performed actions. Timing is, when you are developing firmware, is a key factor, because you need to focus on which is the period of attacks it will be performed, and sometimes we need to use events for perform a specific task as well. So event trigger loop to reduce the power consumption of the application is another of the basic functions. And I think that I have duplicated this list, so we can go to the original description of that to look at the other functions, which are basically related with the BLE stuff, the AT command management, and BLE UART to use as a debug feature as well. So the ending comment was most of above I usually have in my application, and I do not want to rewrite it every time I start a new application. So that started with the repo that I opened before, which is the quick start samples repo in the Burns GitHub account. And the thing is that in order to make easier that configuration and that approach, it's now available as a library, an Arduino-like library, which is called WisBlock API. This allows to separate the LoRaWAN and BLE handling from the user application. What is that? That you can focus only on your application, and all the other LoRaWAN and BLE and other configuration stuff is already done for you. How is this achieved? WisBlock API takes care of all the LoRaWAN and BLE and 80 command functionality, and it makes the development of event driver powers saving applications easy. We are going to focus in more detail on the code and the files structure, how is the project organized, in order to understand a little bit how is this done. This is a block diagram of the API and application part. It's basically divided in two sections. The first one is the API stuff, and the second one is the application. This part is our focus because this is already done in the API and all the functions and definitions that this involves. So that was like a quick introduction about how this project started and which are the main ideas behind this. But all the documentation is available on the repos. So Maria already shared with all of you in the comment sections all the links that you can go to read a little more in detail about all this. But today we are going to focus on what are the things that this allow us to do. And that's the reason why I prepared a demo for this. Maria, you are mute.
Sorry, thanks. Thanks, Johan, for this brief introduction about this project. I think we can also like highlight one thing over here is that this project started like in a way that we can say how we can use let's say a container where we put a lot of boxes into it, that each of these boxes are the different functionality that we commonly use on this project. So we want to avoid rework and reprocesses in our developments, and we want to make it easier to move forward. So at the beginning, actually, just to share for all of those who are connected, we were following, like we were preparing a demo for today using the initial one, which was the project that was called the container project in some way, which is the quick started one. But then that was took into consideration for being the base, and we formalized it as a WisBlock API project. And in order to be able to make that change, those some configurations on the setup were changed. So today, Johan is going to explain a little bit more about the technical details, and as well as some of the modifications that he needs to do in order to make it work. However, the idea to bring this project and today with all of you is to let you know about it because it's something that is new and fresh. It's just out of the oven. So we want to encourage the community to start thinking with it, exploring it, giving us feedback about it. And also, if you want to contribute in some way, we are super happy to listen to you. At RAK, we are always listen to our community in order to improve our solutions. And this is, and as well as the WisBlock, this is an open source project. So you are open to just fork it and include anything that you consider relevant to it in order to make it much better each day. So Johan, feel free to jump on that technical side of the demo. And yeah.
Okay. I have here in Platform IO a basic project that I call the template. This template, it
Johan,
has...
not sure if you can zoom a bit the screen.
I think that I can do that.
Okay. Yeah.
Is it better?
It increased a bit. Yeah, it's better.
Okay. So the project structure is you include the two basic libraries. The first one is the library to handle of the LoRaWAN stuff, and the second one is the WisBlock API. This is done in Platform IO, including this link or by installing it in the libraries option, looking for the WisBlock API. At this moment, there are some modifications that you need to do in order to make it work as I'm going to show today, but we are working on making a little bit user-friendly in order to run easier. That because at this moment there are some modifications to do in order to achieve the behavior that I'm going to show right now. So how is this project organized? We have these two files, the app files, one header and a source file. And as in the blocks that I show in the presentation before, our focus, it will be in these two files, which are the application files, and the other ones are inside the library, so we don't need to change it at all when we are using the WisBlock API. And this library, there is a configuration file, is the WisBlock API, where there are the events of the application that the application will need to identify, some BLE stuff, for example, to initialize the BLE, things like the advertising, some focus in the LoRaWAN configuration. This is the default LoRaWAN configuration. The flash memory function. This is very useful in order to keep our LoRaWAN configuration in a section of the microcontroller to allow us that every time that we flash a new firmware, we don't need to modify our LoRaWAN credentials. Some function to handling the power management things, and ATI command parser, and some configuration specific to the API. For example, set the version of the project we are working on, and the credentials. And here we have our main focus, which is our application. In this section, the first section is the setup app function. Here we call all the functions that we need to call at the very beginning of the setup, for example, to enable the BLE functionality. And this other function is the app event handler, where we are going to handle all the things that our application is going to detect. For example, in this case, this function is triggered according to the status of the application. And in this case, we are going to construct a LoRaWAN payload, a very basic LoRaWAN payload, because this is our template application. So it's going to transmit the frame counter as characters, and there are other functions to handling the messages received over BLE. So if I flash this application to the WisBlock that I have connected over here, I will share this in this moment which setup I have connected. This one. So I have a WisBlock ready to be flashed, and I will flash with this finger.
So basically, like just to summarize what you just shared, we have like two main files, which is the one that have all the pre-configuration, so we can just set up all the things that we need, such as like let's say the region, the configurations that we need for our firmware, let's say the version of it, or some essential keys to integrate our fleet of devices in a network. But then we can just jump and change, let's say the device AY, sorry, which is the one that identifies my device in a specific network, but I can, let's say, pre-warn the other keys in order to make it easier to integrate it to the network, as well as setting other configurations. And then the second file is the one that allows us to just work on the applications that we want to include in our solution, those applications that are new, that are not pre-configured, and it is not like the initial standard that we used to use in order to start a LoRaWAN or LoRaWAN application using WisBlock.
Yeah, that's exactly the whole idea of this. For example, when we flash this configuration, which is the process that is going on here, we are going to have a default configuration that we can interact with it basically in two ways. The first one is the serial interface over 80 commands, and the second one is BLE with the Burns application. Burns it's working on an application to use it as a configuration tool as well. And this is failing to flash the finger. I will This is
It's
taking a little
kind
bit more than I thought.
of yeah, but I think because you didn't pray the demo live gods, that's why. No, just kidding. Let's see. So here you're uploading it, scanning the dependencies. Maybe like the you don't have the just to make sure because that happened to us last week, with our guest that the things that he had the this open the serial open on the terminal. So maybe I'm not sure if you have the serial port open on the serial terminal, and that is why the platform IO can upload the things on into the device. But yeah, I think it's working.
Let, let's give it a second.
Available mode. If right now, if you go to the terminal, like to the command terminal, what you can see, the other one, the external one, not the one from platform IO, the last one that you have. Or where what terminal do you use to send the 80 commands? Waiting
Uh,
for it any.
I'm using the serial monitor in the Arduino IDE, but
Okay, cool.
I don't have it open right now.
Open it. Okay. It's the same.
Okay,
Upload and come. Yeah, got
I
it.
think that
Mm-hmm. Yeah, yeah, yeah. Nice, nice.
maybe it's
Yeah,
my
it's
computer is a
loading.
little slow.
No, no, that was because you didn't pray the demo live gods, I'm sure. That is how hardware works sometimes. It's funny because we can be like, over a night super late working on something and we found a bug and it is not working, and we stay super late trying to figure it out, and then we wake up another day, okay, this is a new day, let's try to find that bug that I couldn't find yesterday, and then you run it and it start working like nothing happened. It's like, what happened here?
Yeah.
But
So
yeah.
I have here the serial monitor to show all the logs that are being recorded in the WisBlock right now. So these are the default keys that the firmware it has. So if I want to register into a network server, I don't need to modify it directly in the firmware. I can interact with the WisBlock through this serial interface in order to modify those keys. So I can go to one of the network servers. Let's use this time the Helium network server. The organization for demos that I have over here.
Yeah, I think it's your computer. Well, but in the meantime, we have a question from Leroy. Oh, okay. Well, you can just jump on this, and as soon as we make the configuration, we can jump on those questions.
Okay, yeah. So I have this device I called here the number one, and I'm going to update the credentials for this device right now with the 80 commands. For example, the first 80 commands that I'm going to run is the one to modify the device EUI. This is this AT def EUI equal to the one that I have over here. This updates the configuration into the flash. The other command is to update the app EUI. And the last one is to update the app key. So we can double check that these credentials are the same that we have over here in the healing console. And I will open the debug view in order to start the join procedure right now, because by default when we flash the firmware the first time, there is no join process enabled for the first time. So I need to use this command at join in order to enable the join, enable the auto join every time the device resets or power ups, the period that every join retry it will be performed, and how many join retries we are going to have. So if I send this command right now, there is a initialization of the LoRaWAN stack, and we start to receive the join requests and all the app links right now in the healing console. And the default configuration that I have at this moment is to send those messages every 2 minutes. So there is another command to modify the transmission period. So I don't need to flash a new firmware to do that modification, and I can do it in this way. For example, 30 seconds. And this updates my configuration, and I will need to perform a reset, which I can do by clicking the WisBlock reset button, but I can do it as well through this serial interface by running the command atz. So I'm going to start again with a new join request and a new join accept. But this time, the uplink messages are going to there will be join uplink messages every 30 seconds. We can check that right now, looking at the time. Let's wait a little bit for the next one. And
this is like, it's super cool because now you don't need to reflash like everything just to make a change. Maybe if you want to if you have a test device that you are working on, maybe let's say that you are exploring different network servers for your LoRaWAN applications and you are using the same device. Now you don't need to reflash anything, just need to change the keys, since the basic of the protocol is the same and works for the different network servers. So let's say that you want to jump this device and integrate it with the Things network, and without needing of reflashing anything, you just need to replace the kit and it should immediately work with other platforms as well.
We are going to try that in
nice.
a few minutes.
Cool.
Okay, these are our uplinks
Uplink message.
every 30 seconds. And if we take a look at the book view, we can inspect how the payload is in, and to check if everything is working fine in the LoRaWAN message itself.
Super.
So these messages in the healing console, when we don't have an integration attached, are encoded in the base 64 format. So the next time I receive an uplink, I take this value over here and decode it here to inspect if everything is working well. So this is my payload, the uplink counter with the frame counter. It's 4. That was the frame counter over here, and that was the message that I shared with you before about which payload we are sending with this basic template, which is this one. So if I try the same for all the other uplinks, the message it will be different according to the uplink counter. So this is the one of the options that we have to set up our keys. And if I wanna try this configuration with a new WisBlock, for example, to flash the same firmware and to try, I can do the same procedure to update the keys, and but we have another option to do that as well. So I will show you that other option by connecting this new WisBlock and flashing the same firmware. I hope this time it won't take so much time. Is this one?
In the meantime, when this is uploaded to the board, we can jump to a few questions that we have over here. What do you think?
Yeah, you can do
Sure.
that.
Cool. So we have a question from Leroy. This container is still running essentially as a super loop application. In that correct? It is not using Rtos task on preemption, correct?
Yeah, about those details of implementation, I can go to the Burns description of the project, and I'm sure we are going to find that the project is using Rtos. Yeah. So is using free RTOS. It's not using that big super loop, and is using RTOS, an RTOS mechanism in order to wake up the microcontroller only when it's needed. No, it's not checking all the time it's not checking all the time infinite loop. It's only waking up every time an event is triggered. So
Nice.
I hope that answers the question.
Yeah, actually, we have other one that is also related to this matter, and it is that there any thought of exploring implemented Rtos preemption within the user application, for instances, migrating the user events in Rtos task. I will say that based on the comments that Bern have, well, the documentation that Bern has shared over over the repo, it is already working in this way. Well, using free RTOS, right?
Yeah. And we can. I think that we already have a conversation about this in our RAKStars Discord. And thanks, Leroy, for sharing these ideas for here. And I'm sure that Bern will give us more insights about this in that channel.
Super. And another one, it's from Julio Aguirre. The same tools are available for Narrowband IoT models.
This is not ready yet for the cellular auctions. This is more focused right now on the LoRaWAN side. But I think that in the way that the team is organizing these files, this library, maybe we can start to add more layers to support more features in a feature.
Awesome. Awesome. So yeah, those are the questions that we have by today. Thanks, Leroy, for understanding. And how is the process, the uploading processes? It's
I think
already
that
on the.
it's already done.
That was faster than before.
Yeah.
Cool.
So I will use my cell phone over here in order to connect to the WisBlock, and I
Just
will
to make
try
sure.
again.
Yeah, exactly. Just to make sure. Are you sharing your? Yeah, that's right.
Yeah. So this is the burnt application that we can use to connect to the WisBlock, and I will open the serial monitor as well in order to inspect some interesting events that we are going to start receiving every time that we make a configuration over here. So I will open the app. There is a module called LoRaWAN setup, and if I press this option,
Hey Johan, sorry, can you move a little bit the console to the right? The Arduino console. Yeah, much better.
okay,
Now we have it. Thanks.
okay. The first time that we are going to do a configuration, the BLE advertising. This is the time that device is discoverable by other devices is just a few seconds. So that's the reason why I perform a reset in order to connect to the board at this moment. So I connected to that WisBlock at this moment, and I can start to modify all these keys and credentials, and in the same way that we were doing that with the AT commands. So for the device EUI, since the WisBlock it has a QR code printed in the board, I just scan it here, and I will go to the Helium console to look at this new device, LoRaWAN credentials, these ones, that I have over here. And the phone screen that I have here. I'm going to copy and paste those credentials that I have over here to the app, and the app key. And once I press this button in the app, the configuration, it will be updated into the flash, and we are going to see a log message over here saying that a new configuration is received over here, and which are those new credentials that I have, that I already upload through the application. We can check that they are the same. And right now I can start the join procedure as well in the same way that we started the last time. And open the debug view over here. So this is a join request, join accept, and we start to receive new uplinks message. But this time doing all the configuration using the mobile application through BLE.
I have a question over here, is that can we reset, like, since you need to upload, like, you need to handle the first join procedure manually, and then you can enable the auto join processes. When you're using the BLE option, are we able to do that reset over the application, mobile application, over BLE?
Yeah, there is an option here to reset the node.
Okay.
This time I start the join procedure over here. The first one, it's because I didn't want to reconnect the serial port again.
Okay, cool.
And the second one is because the auto join option in the app is not working so well at this moment.
Okay, cool. That is good to point out, but it's just to clarify that that can be also be done over the application, because the idea is to handle like both solutions smoothly, either for serial communication or for let's say a remote communication over BLE, that you have this device deployed and you need to, let's say, migrate it to another network, or you need to just replace a key for another key for security purposes or reasons, and you can just go be near to your device, connected to it over your applications, and you will be able to handle all the same changes without the need of take it out wherever the device is deployed.
Yeah, sure. For example, if I want to apply the same change to the transmission period right now, I can do it through the application as well. For example, those 30 seconds again, and send a new config and reset the node, this time from the application. So this starts, that disconnects the device from the app because a new reset cycle is performed. However, we can start to receive our message just right now and with the new transmission period.
Super nice.
So as you can see, we use the same firmware for both devices, but we use two different alternatives to set up the keys and all the LoRaWAN configuration stuff. And in the same way, if I don't have, for example, the source files in platform IO, there is an alternative as well to flash only the firmware without taking care of the source files, because the functionality of the code, it allows me to do that through using other alternatives. So this is, we have two devices working with the same logic, with the same source code, but only modifying the things that we need for every one of them. So maybe this is a very basic example, so we can go to our WisBlock number 1 to update a new application. In this case, I'm going to flash an environmental example in order to confirm that if I flash a new firmware in that board that is sending messages right now, is this one, it continues sending messages, but I'm going to update the application to send a new payload and to flash that new application. It won't affect my previous LoRaWAN configuration because they are already saved into the flash memory of the device.
Finishing loading. It's building, linking, checking.
This is the last part of the process. And we can prepare our serial monitor to check our logs and open the debug view in the Helium console to inspect our new application behavior. I think my trial ports are a little lazier when I train them.
We have meanwhile we can jump on some insights that Leroy is sharing as well over here. And is that, do you know of any way to know the LoRaWAN providers via any over the air mechanisms prior the join attempt? thinking if I am in the range of Helium and the Things Network and SetNet.
Okay, maybe before I join attempt, I think that that's a little tricky because I don't know if I
Good.
have available that specific network server in advance in the firmware when before trying to join a request. Um, but maybe one of the mechanisms that we could try, it could be, for example, if a join a procedure fails for the first time for a network server, I can try maybe with a different set of keys a new join procedure to another network server. But that is something that maybe it's not so easy to do at the first time. You have to think a little bit more.
Yeah, yeah. Actually, I think that is super related with feedback. I would can say that he is providing us that would be nice if my app could dynamically determine the network provider and supply the appropriate credential for it, and probably something for the future for sure. This is something that can be super valuable to evaluate in this development, and also like as I mentioned in the beginning of the session, the idea of presenting this project to you guys is to encourage you to start reading about it, thinking with it, and if you have any feedback for us that we can start implement it, we are super happy to do it. So, and also if you want to contribute in some way, we are super happy to open a private channel with you and be able to start collaborating with your ideas to make of this project a better solution for everyone.
So when we were talking about these ideas, this process to Flash, it's already done, and we are receiving our new uplinks over here, and we can uh, see that this payload is completely different
And the other one.
from the other one that we were checking here. So in this case, as is the environmental data from the sensor, um, I already have an decoder over here in order to decode that payload. So we can,
Just wait for the other message and see the payload decoded directly on the Helium console.
I hope.
You hope?
Yeah, because sometimes the label association when I
Association.
yeah yeah okay, it's here. Sometimes that process it's no so quick. So
Okay,
in this case, we are lucky. Okay, yeah,
nice.
this is our decoded payload. This is the temperature over here, and the pressure, the humidity, and
The
gas.
gas.
So as you can see, I didn't change the credentials, even though I'm using a new firmware. In the past, maybe if I were using a different approach, if I need to flash this example from the WisBlock examples, in every time that I flash the firmware, I needed to flash the keys directly on the code. This time, as the keys are already saved in another section of the flash, those credentials are can be shared between different applications, or when I need to update something in my application logic. So this is working over here,
Nice.
and if you we can try to make the we already made the switch from an different
From one.
from one application to another application with a different payload.
Mm-hmm.
Um, we already done a configuration in a new device. So the last thing that we can do is to try another network server.
That would be awesome. We are already like jumping out of time, but we are directly from the rack team, and we can stay over here for a couple of minutes more. And I'm pretty sure that all of those who are watching will love to see that change of network. So let's go ahead.
Okay. Da-da-da-da-da-da. So I have an application over here in the things stack. I already registered an end device with the same device EUI that we are using here, which is this one. But in order to avoid conflicts between network servers, I'm using a different set of app EUIs and app keys. So those are the ones that I'm going to update for the device right now through over the serial interface. I will open the serial interface over here, and I can run AT to check. Yeah, to check this is working right now. And let's say that I want to update the keys with the command AT app EUI. The device EUI is the same, and the app key is this one. So let's double check these new values here. That is 60 and AC. So this time, in order to perform a new join request cycle, I will need to reset the device again. One important thing around here that is that I wanted to show how to change the region, because this gateway that I have here in the things stack, I'm not using the same region that I was using before. This one, for this demo, for this testing purposes, is using the US 915. So that is the band 8 over here. You can find all these numbers in the repo documentation about the AT commands.
Mm-hmm.
So this time I will change the region with the option 8, and I will perform a new reset. So I
And since
have,
the auto join is enabled, it automatically joins to the network after it was resetted.
yeah.
Nice. Nice. So here we can, let me see. Yeah. Join accepted. Nice. That was super cool. Let me see. Since I have it like on a small screen over the streaming platform, I was like, okay, I couldn't see it. But I imagine everyone it's directly on YouTube and they can see it in a bigger way. Let me see. Sorry, here we are.
So
So, mhm,
that device is now communicating with Helium at this moment
anymore.
because it's using a different set of keys, and yeah, that was our switch to the Things network, and yeah, that is all the demo for today.
Super, super. That is was super cool. And also, we have a comment over here from Leroy that he appreciate all the team has done to help us and developers use WisBlock product. Great job. I will say that we appreciate to you for using it and also for testing it, for create projects, for providing feedback, for providing suggestion for us to be able to move forward with this development in the most efficient way to create a product that is super viable, super easy to use, and robust for the IoT community worldwide. So thanks to you, Leroy. Thanks for joining us. Thanks for also sharing your insights and for leave your questions as well. So no, I think that is like all for today. Johan, thanks for this introduction. This is just the beginning of something that we are working on. This is a big effort that our team has put in off, and Bern have put in a lot of effort. And the idea is that all of us keep pushing out the use of it. And if you have any idea of how to collaborate or how to move forward with it, please let us know. I will be super happy to address something to do something together. Johan, thanks for working on this for us this week. We had some couple of last minute changes on these last deployments, so you were like running with some few changes to make it work for today. So thanks a lot for bringing this for the session, and also for all the things that you are always sharing to us on the different channels as well with the community members every time they have a doubt about any project related to Helium or related to RAKwireless products. So I think that's all. We don't have any additional question over the chat. Thanks to all of those who connect today. If someone is watching this video later, feel free to address any question you may have, and we will super happy to help you with those. I don't know, Johan, before ending the session and saying bye, you have any message that you would like to share with our community of entrepreneurs, makers, and engineers like yourself?
Continue using the WisBlock for your awesome projects, and don't hesitate to giving us so many feedback as you have been doing until this time. And thank you for watching us.
Thank you so much. We hope to see you next time. Enjoy the rest of your day, night, depending where you are, and happy weekend and happy hacking, folks. See you next week. Bye bye.
Bye bye.